After we've completed translating the body of the function into MIPS, we're in a good position to start working on the prologue. Recall that it's in the prologue of F2 where we create F2's stack frame. To begin with, we assume that the stack frame of F1 is here. This means that we currently have a stack pointer, which is pointing to the top of the stack, and we have a frame pointer, which is pointing to the bottom of the stack frame for F1. This can be a little unintuitive because the stack grows down. So in our diagram, the top of the stack is physically below the bottom of the stack. The first thing we're going to do is to decrement the stack pointer, thereby creating a stack frame for F2. So that's simply going to be an add IU instruction, where we are going to take the value of the stack pointer, we're going to decrement it by some amount, and we're not quite sure what the amount is yet, and put the result back in the stack pointer. This has the effect of creating a stack frame for F2, which will be here, and the stack pointer is now going to point to the top of F2's stack frame. The next order of business is saving the return address onto the stack. We'll use a store word, and we're going to store the return address somewhere on the stack. Now this somewhere is in fact going to be the very bottom of the F2 stack frame. But since we don't yet know how big the stack frame is, we can't include the offset in the MIPS instruction just yet. Next, we'd like to update the frame pointer to point to the bottom of the F2 stack frame. Before we do this, we want to save the value of the old frame pointer. We'll do this by using a store word, and we're going to store the current value of the frame pointer, again, somewhere on the stack. And in fact, it's going to go right here. Now we can update our frame pointer by decrementing it. So the frame pointer is going to now take on the value that's going to be the stack pointer incremented by some amount. Now what we want is the frame pointer to point right here. But since we don't yet know how big the stack frame is going to be, we're just going to put a placeholder in here. Now keep in mind that this is just how I like solving this problem. If all of this variable decrements and increments is really stressing you out, then you can actually try to lay out the stack frame ahead of time and figure out how big it needs to be. I sort of like playing it by ear, solving the problems one by one, and then going back and filling in the amounts. But either way is a perfectly reasonable way to accomplish this. So believe it or not, we're almost done. And now we have to handle the calling convention responsibilities. The first responsibility we have is to save any callee saved registers that we happen to be using. Now, this question told you that you need to save one of the values into S1. So we're going to have to save the old value of S1 onto the stack so that we don't corrupt it. This is in case F1 happened to have an important value in S1. We wouldn't want to get rid of it. So we're going to perform a store word that's going to store the value of S1, again, somewhere on the stack, and we're going to put it right here. So F1's S1 goes here. And the last thing we're going to want to do is to put the argument to F2, which is currently living in A0, into a safe place onto the stack. Now, if F2 didn't call any functions, we wouldn't necessarily have to do this, but F2 is going to call F3, and we've already seen that after the function call to F3, we're going to need the value n right there. So we're going to want to put this somewhere safe, and that's going to be on the stack. Specifically, the 3410 calling conventions that we use tell us that F1 has already made space available on its stack for any arguments to F2. That means that we can actually place the value of A0 onto the stack frame for F1. Specifically, we can put it right here. So we can do a store word of A0, and we actually know what the offset needs to be here. It's going to be 4 from the current frame pointer. So again, the current frame pointer is pointing right here, and we're just going to do 4 up from that right there. So at this point, all of the code has properly been translated. The only thing we haven't figured out is exactly how big the stack frame needs to be. So we know that we need room for the return address, we need room for the old frame pointer, and we need room for F1's S1. One of the other things we realized when we were working on the body is that we're going to have to store the value of X on the stack because we're going to need to have its address. When we call F3, we needed to save the caller saved register T1 onto the stack. So that's going to have to go here. So that's the saved T1. And the calling conventions we're using in this class require that we always make room for 4 arguments to a function as long as there are 4 or fewer arguments to the function. So that tells us that we're going to need to make the stack this much bigger, and these would have room for A0, A1, A2, and A3 respectively. Keep in mind that this is room only. We don't need to store the arguments to F3 onto the stack. We just have to make room for them, much like F1 was so gracious as to create room for our A0, which is where we stored it for safekeeping. Now we're just going to figure out how big our stack frame is. So we can create some offsets here. Now that we've done this calculation, we can see that our stack frame needs to be 36 bytes in size. So we're going to decrement the stack pointer by 36. We're going to store the return address at 32 bytes offset from the stack pointer. We're going to store the old frame pointer at 28 offset from the stack pointer. The frame pointer is going to be 32 bytes higher than the stack pointer. F1's S1 will be stored 24 bytes from the stack pointer. Now we can go back to the body and update the offsets for those 2 MIPS instructions. First of all, we're going to store T1, offset 16 from the stack pointer, and the address of X, which needs to ultimately be stored into A0, is going to be 20 bytes from our stack pointer.